In the beginning, there was nothing. And then, bang, AEL was born. Astro's Electronics Lab brings you entertaining, sometimes silly videos relating to electronics for your enjoyment. Follow along with his frustrations and antics and maybe learn something in the process.
Greetings, the Astro 30 here, and I've received a package. Now, this is going to be the output IC for that Kenwood power amplifier that I ordered a couple of weeks ago, about a week and two and a half weeks now. It's the output module IC, and it came from China, and it does state in the Evil Bay link that it is brand new, not a pull. Well, we'll soon find out. Now, the authenticity of this IC is in question, because as Kenwood has made this particular IC for several years, it's debatable whether or not it's going to actually work. But sometimes you can be lucky and get an IC that works just fine. So, but I am hoping that the switching comparator IC that goes in between two halves of this output IC isn't damaged. If I can even get the package open, which would be completely nice, but sorry, I just took the tripod. Okay, there is a box. Well, piece of cardboard folded up as a box. So let's see what we've got here. I mean, it's obvious it's an IC, and if you saw the last video on this particular amplifier, you would have already seen the IC in question. I'll put a link in the description to that video where I found the fault. Now, okay, looks good, so I'll just remove the bubble wrap and rubber band. Printing itself looks okay, so there it is there. I'll just remove this protective thing, and all the pins are bent. Of course they are. Text is a little bit, how you doing? On closer inspection of these pins, it doesn't look like a pull because there's no solder on it. But yeah, I'm going to have to carefully straighten these pins back out. So we've got the shorter module here on the left. Quick comparison, the text looks a lot bolder here. Doesn't rub off. Yeah, there's an index mark here and here to denote where pin 1 is. The screw holes look the same. On the other side, it does look similar. The lead length is the same. So, all well and good so far. So what I need to do is I need to carefully straighten these pins out. Now, this is known as a SIP22 device because it's single inline profile, and it's got 22 pins. So just going to straighten these as best as I can. I mean, I am going to put the little plastic thing, retainer, on the new one in a minute, but what I want to do is I just want to make sure that these pins are as straight as I can get them, and that all the, I thought I just straightened that, just bent again. I tell you, these pins are very easy to bend. Alright, that's probably as straight as I'm going to get it. Now, this is known as a Class G amplifier. That is, it uses a switching IC in between the two halves of this output stage, because the driver and VBE multiplier is one half and the output transistors is the second half, and it switches between the two power supply rails, the plus minus 65 volt and the plus 35 minus 35 volt rail respectively. So it has a higher power output transistor section and a lower output transistor section, and it switches between the two depending on, you know, the demand. Now the next thing I want to do, before I get too carried away, we actually have access to all of the output transistors, base, collector and emitters, which is handy via these pins here. And the old one is shorted on two of the positive side transistors, the low and the high, and shorted on the high side negative rail. So that means that the output, or the collector and emitter junctions of both sets across the power supply rails is actually shorted, so that the power supply rails are actually shorted together. That's why there was a short there. And only one transistor on the negative 35 volt rail actually survived. It still functions. So we've got one transistor between pins 10 and 13 is a collector and emitter junction. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, nothing. 21 is the base, but I'm not going to worry about that. The second transistor is pin 18 and pin 16. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 and 16. Nothing, so that transistor's fine. Third transistor is pins 12 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 9. Nothing. And the final transistor is pin 15 and 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 17. Nothing. They're completely open. So that means that the output side of this device is so far not shorted. So I can pop that into the amplifier. Now I've got to get this thing off, but it's kind of, there we go, it's hooked on the solder. This is just like a locator retainer. So I'm just going to put that on and try and straighten the other pins so it falls into line. Now I'm hoping that the switching IC survived, like when the base, collector and emitter of one of the transistors shorted, it didn't feed back that voltage into the chip that controls this IC, taking it out in the process, because I'd be very annoyed because I haven't actually ordered one. And there's no real way to test for that unless you've got a working outputs IC. So hopefully it all goes according to plan. So what I've got to do now is I've got to put the unit back up on the desk, take it apart, take the bottom off. So I'll strip the unit down ready to accept the IC, and we'll go from there. All the necessary metalwork has been removed and the underside of the unit has been exposed. Now what I need to do next is I'll need to apply, don't know why there's heatsink compound on there, need to apply some new heatsink compound on here and mount it to the heatsink. So I need to go and find what I did with my heatsink compound. I found it. I think there's still some left in this old tube. So I'm not going to put a terrible lot amount on there, just enough to, you know, cover the device. There's not much in there now. I want to try and use up this tube so I can throw it out. So I'll just spread it around a bit. It will spread out when you put it in up against the heatsink. Excuse my sniffing because I've had sneezing fits all morning. I think I'm going to safely assume that that's going to be enough, and I'll just use the rest of the tube up. There's not much left in here. because it is quite a fair big area to cover. So I think that that's plenty. So I should really clean off the old stuff, and I really should redo the other one, but it's still pliable, so I'm not going to really fuss too much about it. Actually, I might do this another way. So my biggest concern is as soon as I power this up, it blows the new IC straight away, which would be fairly annoying. I've had that in the past with transistors that I've purchased off of eBay, and as soon as I put them in the amplifier at plus minus 50 volt rails, it just blew them instantly. So I'm hoping that is not the case today. I mean, I've had a fairly good success rate with some Chinese ICs, so... And let's face it, when this unit was probably mass produced back in the 80s, that you probably find that most of the ICs that go into this are made in China anyway. So it's kind of a non-issue. So now I've got to try and feed this in to PCB holes. There we go. Now I just need to get that plastic thing to locate in, and now I can put some screws in. And that should pull it straight. I'll tighten up the screws before I solder it. That way it brings everything straight. Is that doing up or not? I've missed the hole. It's because the IC is down too low. There we go. Alright, that's bit in. I'll see if I can find something that'll go in here to do it up with. Now I've lost my screwdriver somewhere. There it is. So, because, yeah, that IC, this driver IC is kind of in the, well, it's not driver, it's a switching IC, is kind of in the way. So I don't want to damage anything else. Well, it looks like this multi-piece screwdriver set has just paid for itself. See how it all just started to squish out? That one's going to be a little bit more awkward to do. We might be able to tighten it with the screwdriver. And finish it off with a pair of pliers. I don't have a small enough spanner to get in there. So those are nice and tight. Excellent. So now it's time to solder it in, and then we can test it.
Astro is currently soldering the pins of the SIP22 device. He is hopeful that that is all that is wrong with this amplifier. If it's not, then expletives may be uttered.
Really? I have a narrator now? Son of a bitch! Ran out of solder. Lucky I have a new one. All jokes aside, it's done. It's soldered in, so now I can put the bottom cover back on so I can turn it the right way up, and the back panel might as well. So I can get ready for testing. I don't think I need to be in here anymore. All the other joints look okay, so whilst I'm at it, I'm going to resolder that ground lead that goes to the back panel. Thanks for reminding me, because that's not soldered properly and it's just spinning around in the hole. It wasn't even making a good enough connection. So I should have continuity between this point and the wire now. Indeed I do. Excellent. Might give that joint a quick solder too. That doesn't look too great. There we go. Let's fix that. Alright, so yep, now it's time to put the bottom panel back on, and we can go about testing it. Now, I'm going to get all the screws started so it pulls this bent, twisted metal thing into place, just so that all the screw holes line up and, you know, it doesn't sort of like get itself into a bind. Excuse my sniffing, I've just had another sneezing fit. I don't know what is wrong with me. It's 2 days in a row now. So I can then tighten these screws up now, as the panel's flat enough. And then I'll move on to putting the back panel back on, soldering that ground lead back onto the post that comes outside to the outside weld. Alright. That's the back panel and its peripherals reattached. Now to resolder that ground lead. I reckon that is soldered for the most part. It's connected anyway. So I'll just check to see if it is actually grounded. It is. Excellent. 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 Everything's grounded as it should be. Sweet. Okay, first part of testing is a power on test to see that nothing self-destructs. Through a dim bulb, of course. So the unit is currently off. Let's try it. Well, okay. That's not a good sign. That's because we've got DC at the output of that IC. That is disappointing. That means there's a possibility that either the IC I've just put in is bad, or the switching IC that goes to it is also damaged. Alright, so with this thing, I want to test the obvious. I want to test whether or not the output stage of this new module has now got a shorter transistor. So I've got a clip lead connected to the center point of this compound resistor going to my negative probe. And I just want to see with the other probe, while probing around these bridge rectifiers, especially on the negative side, whether or not we've got a direct short. So that one, that one, that one, nothing there. Let's try this rectifier. I don't know if I can quite get in there. Yep, I can. Doesn't appear to be a short. So it's leading me to believe there might be something wrong with this particular switching IC, which is quite possible. So, oh god. So what I have to do is bend that capacitor back up, is I'd have to measure some voltages on the pins that actually go to the bases of the output stage, because this module sits in between one half of this IC and the output half to control and switch between, well, whether it's going for the plus minus 65 volt rail transistors or the plus 35 minus 35 volt rails respectively. I just want to see what voltages are being driven at the base. There's a convenient ground here. Now, shit. So the unit is turned on, connected to the dim bulb, but the dim bulb is off. So I'll turn the dim bulb on. And if I measure what's here, minus 35 volt. Okay, so the PNP transistor in this case is probably being driven hard on at the base. So because I've got a working channel, I can measure what voltages are coming out of this IC, comparing it to the same pins on this IC, and see if they vary wildly. If they do, then yeah, that's the fault. Most likely the chip itself. But to rule that out, I want to just check what's coming off of the driver side half of the IC going into this IC before it switches it and comes back out. Just to, you know, make sure that this IC isn't rubbish. Alternatively, I can take the good chip out of this side and swap it out for this one over here, just to see if this channel now operates. If it does, well, it's a good indication that this chip is destroyed, which, considering the old module, one of the output transistors was short of base collector and emitter, probably sent, well, in this case, the positive supply voltage rail, 65 volts, up into this, and probably fried it in the process. Alright, I managed to get the bottom off without having to take the back off, which is nice. This is the IC in question down here. Pin 1 comes off of the driver of the output IC to the PNP side switching, and pin 2 next to it is actually what's driving the base of the PNP transistor. So if I measure across pin 1, minus 50 volt there, so we've got, and if I measure pin 1 of the other IC on the good channel, it's dancing around a bit, but it's less than a volt. So pin 2 of the suspect IC, maybe, minus 36 volt. There you go, that PNP transistor has been driven hard on. So if I measure pin 2, the good IC, nothing, hardly anything. So there's our problem. We may have a faulty switching IC. So what I want to do is I want to take this chip out and measure those voltages at those pins again without the IC installed and see if it makes a difference. With the chip removed, let's test those voltages again. Well, the relay engaged, that's a good sign. Pin 1, still minus 53 volt there. Pin 2 has got nothing now. So yeah, it looks like the IC that I've installed is faulty. It should not be doing that. I'll just turn that off. So that means that this is basically unrepairable now, because I won't find a genuine Kenwood IC. So the driver, well, the switching IC is probably alright, so I'll pop him back in. But yeah, I can go no further with this, because I won't be able to find the part. So obviously the driver section of that particular output IC is either fried itself as soon as power was applied, or something else, I don't know. But yeah, I'll pop the IC back in, because there's no point leaving it out. And yeah, we'll basically recycle this now. Alright, in one last ditch effort, I've got the daughter board out. This contains all the constant current sources, mirrors, input stage. They're just basically JFET input chips to give us our long tail pair. And I noticed, after this was a bit of a bitch to get out, but I noticed R14 over here is awfully loose. This solder joint right here is cracked. There's a few other cracked solder joints on the board too. So what I'm going to do is I'm going to go through this board, I'm going to check some transistors, etc., and resolder and flow all the bad joints, and we'll see what happens there. I've resoldered all the bad joints, which is 99% of them, but it kind of stands to reason because this is mounted right in front of the heatsink. This is actually just the input circuitry board, and yeah, that's near a source of heat, so for these joints to, like, you know, dry out is not going to be uncommon. So I've also checked all the transistors on this side. They appear to be fine. So, oh, and the diodes. So next thing to do would be to pop it back in the unit and hope that it works. Now, the only reason I took this out was because I don't know if you can read that, but I was measuring the voltages at pin 1 and pin 3 of that output IC, And pin 1 should have been plus 1.7 volt when compared to ground, and pin 3 should have been negative 1.6, and I was getting like 20 volt there and minus 20 volt there, something like that. So as those voltages are fed off of the input board, I decided to take it out to investigate it. It was actually kind of a pain in the ass to remove. So looking like it's going to be a pain in the ass to get back in too. Might just run the wick over the pins. There we go. This piece of rubber's kind of in the way. Actually, let's face it, everything's in the way. Now, I can't guarantee this is going to fix the problem, but if those base voltages to the output IC are off, then it's not going to work, especially if they're too high. It's just driving the driver stage on too hard. Okay, daughter board is soldered back in. I'll just fix up the first joint I did. Okay, I'm going to leave it upside down for now. Power switch should still be turned on, which it is. No different. Okay then, I'm going to call it at this stage. It's not worth continuing on anymore. So yeah, let's close this one out. So unfortunately, there are just some things that don't want to be fixed and can't be fixed. As I cannot guarantee to get a genuine output IC, which I still think is the problem here, it's not repairable. So I'm not going to waste any more time on this. I've already wasted $36 on that chip, so I'm going to actually get in contact with the seller on EvilBay and tell him that well, the IC is junk, and see what he wants to do from there. I'm not going to hold my breath if I'm going to get a full refund. I doubt it, because he'd probably want me to return the parts. If you enjoyed this video, please remember to go down below and like, comment and subscribe if you haven't done so already. And this is the Astro 30 saying, see ya, have a great day.
Thanks for watching. Please remember to like, comment, subscribe and share the video. I'm Samuel Jones. This has been Astro's Electronics Lab.